Hi guys, I'm Smita and welcome back to my channel where I talk about all things AI and machine learning related. Today is a really special video because I'm going to be joined by Ohad Asor from IDNI and Dr. Enrico Franconi. IDNI, also known as the Intelligent Decentralized Network Initiatives, is a company which is hoping to solve a lot of the problems that exist with today's blockchain with something called Tau. Tau is a decentralized network that IDNI has created, which makes a lot of decisions based on logical AI. Now, logical AI is something really interesting and really cool. And in today's video, we'll be discussing with Ohad Asor and Dr. Enrico Franconi on what exactly is Tau, how does it solve a lot of the problems that exist with today's blockchain, and how does logical AI play a huge role in this? And also, what is logical AI? How does it differ from existing machine learning technologies? So I'm sure this video is going to be extremely helpful for you guys who are interested in machine learning, interested in logical AI, and it's going to be a really interesting video interview to watch. So let's get into it. What led to the creation of IDNI?
There are some fundamental problems in the blockchain world, which extend to more general problems outside the blockchain world. Specifically for blockchain, as you know, blockchain is all about decentralization. However, the most important part is not decentralized, which is the human and the social part. All blockchain networks are defined by a group of developers. If we treat a blockchain seriously for something that is to be taken seriously as something fundamental in our economy, then who guarantees that this group of developers will take the best choices that are good for the participants in the economy, even with all good intentions of theirs? There is no reason to believe so. And they themselves, the developers themselves, are aware of this, and therefore they don't want to take serious decisions. Economy controlled by a small group of developers cannot really work. How can we make a blockchain network which is controlled by its users in a way that can actually work in practice?
So what you're actually talking about refers to the decentralization and centralization of blockchain. So that's a very interesting point that you have mentioned. And so that actually has led you to create IDNI to counteract this problem, which exists within modern blockchain.
We were not the first to identify this problem, but the way this problem is addressed by other projects does not really solve the problem. The way it is addressed in other projects is that users are able to propose code patches and then to vote on those code patches. But this cannot really work for three main reasons, which I say in short, and then I can emphasize. The one is the inability to reason over code. The second is the inscalability of coding. And the third is the inability of code to speak about global requirements. Now we'll explain. Let me start from the end. What do I mean by global requirements? Code is instructions for what the computer should do. Suppose you want to say that private data should never be sent over the network. This you cannot say in code because this is not something to do. This is something what to not do. In order to make sure that your program does not send private data over the network, you need to look all over the code. That's why I call it a global statement, and make sure that this requirement is satisfied. So if you propose a code patch, you still cannot say anything global about the system.
So security is a big aspect that you're highlighting here. So how do you propose, since you can't actually hard code these things, and people would naturally assume that you're making use of something like machine learning or AI in order to identify what is actually secure data and what is not in order to protect it?
Yes, there are, as you know very well, there are two main kinds of AI. One is machine learning, which what everyone heard about. And there is another kind which is less known, which is logical AI. Machine learning is probabilistic in nature, and it is only about learning for examples. So if you want to say that the previous example, to not send private data over the network, are you going to show in your network many examples of programs that do send private data over the network and many examples of programs that do not send private data over the network? And then maybe, just maybe, in some probability, your software will be secure, or you just want to say the thing as it is. You don't need examples. You just say the thing, don't send private data over the network. And that's why logical AI is much more suitable for this cause rather than machine learning. And we have Professor Franconi here, who is a leading researcher in the field of logical AI. He can explain the field and the industry much better than me. I will just say that I believe that the next wave of AI is indeed going to be logical AI.
Okay, thank you, Ohad. So I will address the next question to Professor Franconi. And you've really specialized in the field of logical AI and machine learning as well. And on my YouTube channel, I talk a lot about machine learning, and a lot of the viewers, they're interested in learning about, hey, what is the next thing in machine learning? What is the next field that they should focus on career-wise, etc.? So could you actually give a brief explanation on what's the difference between the machine learning that we have currently, the AI that we have currently, and then logical AI?
So I would say that machine learning is based on similarity. So what we are in order to have an answer to your question, whether you want to get some information from your data, from your system, the only what machine learning does is that, well, what you're asking me is very similar to a number of things already seen, and therefore I can derive this conclusion for you. And it's also about approximation. So sometimes you get, maybe most of the time you've done a good job, get the right answer. Sometimes you get a very approximate answer, and many more times you probably get the wrong answers, because it's maybe biased by the learning set, and your similarity function may not be so good in that particular domain. In particular, here we're talking about software, for example, it's software verification. Now, logic-based AI, it's a very old field, to be fair. And I would say that there is one witness, which is the major example of the success. And probably I would say that 80% of money in IT in the world revolves about this logic-based AI, which is databases, relational technology. Relational technology is all about logic. And the point is that if I have a bank and I want to get some money out of it, I want to be sure that all the computation I'm doing are correct, then probably will use some relational database technology that tells me the exact answer. So there is no approximation, no similarity. Well, this is it, right? I cannot lose money because of that. So I'm using logic to get the exact answer, which comes from the data that I have, because the data has a very specific meaning. We call it semantics. And so, for this reason, logic, again, going back to Aristotle 2000 years ago, is all about trust, all about the fact that what I get is undisputable. So we can discuss as much as you want. I will be always right because I'm using logic, right? Maybe with machine learning, I give a different example. Maybe I can argue about that. In logic, you cannot argue. That's the whole point. So the example of Ohad that do not send private data over the network, well, we can actually prove that this is going never to happen. The second major field of success of logic-based AI is software verification and verification in general, also hardware verification. So maybe you don't want to fly a plane whose software has been, I don't know, programmed by a Microsoft programmer, right? That gives you the blue screen of death. So you really want to be sure that no matter which kind of RAM this or which kind of side effect this software will end up to, it will never switch off the engines or whatever. It will never get into a problem. And then what you do is that you do this verification, formal verification of your software, that some bad things will never happen. Something like you never send private data over the network. Because the software also, in a sense, also software itself, a program is based on logic, because it's run, its execution has exactly one single meaning, modulo possible by bugs on the compiler. So regarding to machine learning, there is this big distinction. But then there is also the need nowadays that machine learning has become popular because it's now effective, because there is more data, there is better GPUs, because machine learning again did start in 1958, exactly the same moment where AI was born by John McCarthy. So both disciplines are very old. They developed in different ways. Machine learning was very lagging behind because its lack of resources, both in terms of data and in terms of computational resources. Now it's successful. And now what can we do with both of these things? So the next step, if you want to advise your viewers with what to do with machine learning and logical AI, is explainable AI. So in Europe, we, for example, have this fact, the GDPR is a major law about privacy in Europe that says that we cannot take decision which cannot be explained about private citizens. For example, you cannot be refused a loan by a bank because a neural network said, well, you are very similar to most people that did not repay back the loan, so I will not give you a loan. Because it's the right of the citizen to ask why. Well, I don't really know why. It's the neural network that told me that, right? And well, maybe this neural network was biased because I was living in the wrong neighborhood, because I'm a person of color, or because whatever, right? And in Europe, this, for example, neural networks in the public administration is completely forbidden as a technology because it cannot give you explanation. Logic would give you explanation, but it's not as effective as with big data as machine learning. So the idea would be, as an interesting development, which is not about IDNI, I guess, at this very moment, it would be this idea of explainable AI. So I will use a neural network that then gives me explanation in terms of logical statement of rules of why it took a decision after all.
That's a very good explanation of what is logic AI, and also what is the major difference between logic AI and machine learning. So would you say that logic AI is relatively new, or has it been around for a long time?
Well, it's very old. And again, as I told you, the database technology was created from first the logic in the early 70s. So no, it's very, very old. Actually, it was the only AI until 10 years ago. And machine learning is very recent in terms of the AI label. AI has been hijacked by machine learning, I would say.
So you could definitely say that logic AI is a branch within AI, and machine learning is also another branch within AI.
Yes,
then.
Indeed, yeah, that's exactly the case. Yes.
And how does Tau? Sorry, and how does Tau use logic AI?
Okay, the idea is that all the description of software and specification and whatever you need to describe as the behavior of this system and the hardware, we'll talk to you about better later on, because this is not really my expertise, what is Tau exactly doing. But the role of logic AI is that all the specification will be done using logic. This means that whatever decision Tau will ever take, will ever impose on the user, will be undisputable. And will collect information based on logic. This means that it will not gather information by looking at similarities or because oh, this may be something like this. No, we'll take the exact information that is going to be told by the users. And with all this information, we'll answer question in an undisputable way. That's because again, in the context of blockchain and cryptocurrencies and all these things, I guess, like in relational database, success stories are in banking, in transactions, in e-commerce, right? Where you don't want to lose money, you want really precision, you want trust. I guess in the context of Tau, this is also quite relevant.
Okay, that's great. And this next question, I think it applies to both of you, so anyone of you can answer. What is the single biggest problem that you think that Tau is going to be solving?
Yes, well, in fact, you can imagine the Russian dolls, the matryoshka, one inside each another, where we have problems hiding bigger problems. We started with the problem of blockchain defined by its users. But inside this, you have a bigger problem. How can any software be controlled by its users? After all, software is there for only one thing, which is the users. It's only for the users. But users have basically no voice of what the software should do, how the software should be like. Next time you install a software update on your phone, you got no choice what this software update contains. Moreover, software development scales very poorly. You know the saying that what one programmer can do in 1 month, 2 programmers can do in 2 months. When you have 10 times more programmers, you don't get 10 times more efficiency. It's very hard to collaboratively create a program, specify a program, let alone by non-programmers. So from blockchain defined by its users, we have the problem of any software defined by its users, but then we reach an even bigger problem. How can any large group of people can take a collaborative decision? This is a fundamental problem by its own, which we call large-scale decision-making. And inside this problem, we even have an even bigger problem. How can a large group of people can even have a meaningful discussion? If you have discussion with too many people, you don't get more utility, you get less utility. How can we combine brain power of 1 million people? How can 1 million people have a meaningful discussion? Well, a solution to all these problems, and also to more problems arising from those solutions, like how to create a knowledge economy, the solution is rooted in using logical AI in order to improve communication between people. And this is our fundamental paradigm, which we call human-machine-human communication. It's all about human-human communication, but in languages which the machine can understand, and therefore can help the discussion. Indeed, the field of logical AI, the industry of logical AI, deals with various solutions to various problems, and maybe in contrast to all others, we specifically deal with using logical AI to improve human-human communication. One example, maybe the one very important example, is the concept of opinion map. Let's see, why do small-scale discussions succeed? Well, how do small-scale discussions look like? Everyone just say what they have to say. They don't need to vote. And who agrees with who disagrees with who, and on what is just obvious to everyone, which is what we call the opinion map. In large scale, we lose the ability to comprehend the opinion map because we just, as humans, we cannot process so much information. But if it was written in languages that machines can understand, then the machine will be able to recover the opinion map. So you could imagine, for example, Twitter or Facebook, where the feed in Twitter or Facebook looks like this user said that, and this user said that. But imagine you could see it in the form, this opinion is held by this and this and this and that users, which is in contrast to that other opinion, which is held by that users, and is a special case of that opinion, and so on. This is not a magic at all if we make the assumptions that people speak in logic.
That is very interesting. So that's one of the biggest problems that you're trying to solve, and also like how you're using logic AI in Tau. And now that you've said all that, who do you think is the ideal users for Tau? Would you say it's everyone, or you're trying to target a specific group of people?
Here should come the snowball mental picture of software that is controlled by its users. If a software, in particular a decentralized network, a blockchain network, is defined by its users, then maybe at the beginning, just maybe, it will be usable and interesting for a very small group of people. But what will this small group do? Well, they will just improve this very software, and by that make it interesting for more and more people. And we get this snowball effect. So we have a social human mechanism for a technological creature to evolve. So we only need to start the snowball, and then it will roll by itself.
So that's great. So initially you are targeting a smaller group of people, and you're hoping that it's going to be adapted by a much larger group of people as there's more and more iterations and improvement within Tau. How do you plan to make Tau a self-evolving or a self-improving software? Or where does that capability come in?
Yes, well, imagine that people just say what they have to say. Just like people already do now. We already uploaded our mind to the cyber. People just write all the time whatever in their mind, but in a way that is not accessible to machines. If the data was accessible indeed, so at one point I could ask Tau how to get what I want. And then it will infer from what I said so far what I want. It will also infer the methods, how to get what I want, and it can answer my question, how to get what I want. Or I could say, I want Tau to be good and useful. According to what good and useful means, according to everything I said so far. So the more information, knowledge is acquired inside the system, the greater the leaps that the system can make and become better.
Yeah, so that's definitely how you can make Tau, I think, a more self-evolving or self-improving system. Now I kind of want to backtrack back to the blockchain aspect of Tau. How would you say that, how are the contracts that are used in Tau different from other blockchain smart contracts?
Existing smart contracts are nothing but code. The code is, again, just machine instructions and come with the problem of lack of global statements, as we said. For example, you want to say that no one who is not eligible to get payment will get the payment. And this you cannot say, because you can only say what to do, not what to not do. And also, existing contract languages in the blockchain world are so-called Turing complete. This implies that it is mathematically impossible to fully reason and answer questions about contracts, about the outcomes of contracts. In Tau, you will be able to write contracts in languages that are much more closer to real-life languages and to real-life concepts, less about machine instructions and more about the objects in real life. Contracts in existing smart contracts, they don't know what is money, what is property. They know to add a number. That's what they do know. But you will be able, in Tau, you will be able to speak in much more human concrete terms about what the contract should do. Another point, which is a point that existing logical AI does not answer, and we had to answer this point ourselves, is what happens if you want, in any real-life contract, you have conditions. What happens if you want to change the contract? It seems very natural. Also, another example is from real-life law. You have law, and you also have laws of changing the laws. To express changing the contract, changing the law, changing the software code itself, which is what we talk about, to change the code itself, is surprisingly or not, is not addressed by existing logical frameworks. And we had to invent ourselves a logical framework that supports such statements. I can give you a taste to logical paradoxes that that highlights the difficulty with this. If you have the time and the patience.
Yeah, sure. If you can briefly summarize it in a few sentences, that would be great.
Yes, well, in a few minutes, yes. So let's say we have a law or right, and here in this, whenever I say law, I mean the behavior of the program. I don't really refer to real life law. So we have laws. We also need laws of changing the laws, because otherwise we cannot change the law. Either that or anyone can change the law. But then we also need laws of changing the laws of changing the laws. Because if we don't have laws of changing the laws of changing the laws, then how can we, then anyone can just change the law of changing the law, and by that change the law. And then you need also laws of changing the laws of changing the laws of changing the laws. So you will need infinitely many laws just to begin with. So what are we going to do? Well, one way is maybe the only escape from this infinite loop is laws that speak about themselves. So when the laws of changing the laws say apply also to changing the laws of changing the laws. So for example, you could imagine a constitution that says, among other things, it also says any new law that contradicts the constitution needs a 60% vote, and otherwise it needs 50% vote. And here comes the logical trap. If you only ask what is, not about the laws themselves, but which language to express the laws, indeed, we are not going to put a system of decentralized democracy on the table and also set its laws. We only provide the language and the framework to change the laws. So you can see that in this constitution example, there are two fundamental features. One, that the constitution speaks about itself, and two, it speaks about whether some newly proposed law contradicts the constitution. Now, if you have those two language constructs, or even just one of them, you are in big trouble. For example, the liar paradox. The liar paradox is, imagine a written sentence that says, this sentence is false. Now, it turns out that this sentence cannot be true and cannot be false. Because let's assume it is true. Then it says that it is false. So it cannot be true because it just said it's false. Now let's assume it's false. If it's false, then it is false that this sentence is false, and therefore this sentence must be true. And we get a contradiction again. The liar paradox is an example of a sentence that cannot be true and cannot be false. And all I needed in order to express this sentence is self-reference and to say that something is true or false.
Would you say that implementing these laws makes use of logical AI?
Yes, but I'm pointing to the problem that existing logical frameworks cannot express those laws of changing the laws because they fall into a similar paradoxes like this liar paradox, precisely because they must contain the construct of self-referential methodological statements. Because if we don't contain self-referential methodological statements, we get the laws of changing the laws, infinitely many laws just to begin with. So we have no choice but to find logical languages that do not exist, which can support such statements.
So how do you, is this been implemented, or you're planning on implementing this? And how do you implement this, making use of, what type of technologies are you going to be making use of to implement this?
We implemented one language so far called TML, which is not intended for what we spoke now, for the law of changing the law. For the law of changing the law, we finished designing a language that answers those requirements, and now we are implementing it. We don't really use external tools. Maybe we will in the future, but for now it's all written from scratch. A lot of the logical reasoning tools out there are not in industrial quality, they are of academic quality. So they don't have wide enough shoulders to carry a whole network and the whole economy soundly. So we will need to write a lot ourselves and adhere to very strict engineering standards.
So a lot of the logical AI software which currently exists, you're saying it's not scalable for enterprises. It's mostly for academic use.
Some of them, yes. As Professor Franconi mentioned, databases is logical AI. And of course, many of the database applications are of industrial scale, but they don't have the self-referential methodological statements. They cannot express the law of changing the law, as we described.
So I think the next question I'll be addressing Professor Franconi. So in developing Tau and in making use of logical AI in order to create Tau, what type of technologies have you made use of? Or what do you, for example, if there's someone out there who wants to learn how to use logical AI, what are some of the frameworks that they should be looking at?
Okay, so independently on Tau, there is now a very popular framework for about logical AI, which tries to put this more abstract logical AI than just databases or verification. So the AI which is able to reason as opposed to just answer queries like in databases or verification. And this area is called knowledge graph and semantic web. You may have heard about that. So that's where ontologies, which are just logical theories, logical expressions, can be written and reasoned upon. And again, this technology is very powerful, is there since 30 years. But yes, as Ohad mentions, I would say there are two shortcomings. First of all, they don't really scale up so much as needed for Tau. And then they don't have this self-referential ability. So what this knowledge graph, semantic web technology, we are taking many things from there because it's there, it's actually working, but we are trying to improve and substantially improve along these two dimensions, namely scalability and ability to self-referential statements, yes.
Okay, thank you for explaining that. And so you've mentioned a bunch of different softwares that someone can go about in order to, if they wanted to learn logical AI or practice with logical AI, they could make use of. Are there any actual educational programs that you would say teach people logical AI?
Well, yes, it's plenty, I would say. All university will have some course on ontologies and semantic web. And there are many industry strength also courses on knowledge graphs. So this idea of ontologies and knowledge graph has become a standard by the W3C, which is the organization that runs the internet. You may not know that I would say 90% of the e-commerce websites around the world actually use logic AI because they are forced by Google, Bing, and various other search engines in the world to mark up their web pages using a logical language, which is called RDF. And behind RDF, there is an ontology, which is defined by an organization called schema.org, which basically standardizes all the terms about e-commerce. And this is because Google likes to better understand what you are actually doing in your shop by not actually trying to parsing all the natural language you've wrote in the web page, but because these web pages are marked up with the logical formulae that exactly explain what you actually are doing. Of course, these logical formulae are not seen as logical formulae by the programmer, by the web designer. They are just hidden in a very nice formats. So basically, the web designer will use this notation, to mark up their website, and Google and all the search engine will understand exactly the meaning of whatever they are doing, so that they can make undisputable conclusion about your website, and they will index in the proper way, and they can return your information in the exact way. And so that's technology that actually exists, is standardized, and is up there.
Okay, thank you, Professor Franconi, for explaining logical AI and how Tau is using logical AI and how people can also learn about it. Now I kind of want to move on to the users aspect of Tau. So users are the heart of this technology. And how can users actually use this? And also, like, how can users make money off of Tau? Because that was something that was mentioned. So how is that possible?
Yes, well, the way it's going to look like is like any other social network, like Facebook or Twitter, where you just say what you have to say, and you have comments and discussions, but in languages that computers can understand, and therefore create the opinion map, and also take what users say about how the program should be like, calculate their consensus, and become what the users want it to be like. And as for how to make money, well, one important example is knowledge economy, because we are all about the ability to formalize knowledge. We can, for the first time, create a direct and efficient knowledge economy. Right now, you cannot buy or sell a single piece of knowledge. No one does this. You go to some expert and you pay because you trust that the expert has the knowledge, but you never buy or sell, trade single pieces of knowledge. But once the knowledge is formalized, then for the first time you will be able to do so. So, for example, imagine a law firm that takes the huge effort of formalizing in logic parts of corporate law. So a company can have discussions in the system, and the law firm will automatically comment in the discussion about legal aspects of whatever raised in those discussions, and charge a subscription payment for that.
And now I want to fast forward into the current stage at which Tau is now. At what stage of development are you at currently? And when do you expect to release Tau or a part of Tau in order for users to start using?
Yes, we finished implementing one logical engine called TML, which is to be used in some aspect of the system which we didn't speak about, which is called the Internet of Languages, which is about allowing several languages to coexist. But beyond that, TML is also, as I said, the logical engine. And it also supports something which we also didn't speak about. It will support soon a proof of execution. In existing smart contracts, all nodes need to execute all the smart contracts as part of the block verification process. But using proof of execution, only one node will need to execute them and then supply a short proof, a short cryptographic proof that the execution was correct. This is using the sum check protocol. And this is possible because of the specific way that TML is implemented, which is using BDD's binary decision diagrams. This enables us to use the sum check protocol. We're also working on implementing the logic for the system itself that supports the law of changing the law and the logical properties that we spoke about. We also have some way to go in how to turn this whole logical framework that we have into a framework that allows to speak about programs. After all, it is all about programs, a program that changes itself. And this is something that we are currently researching. I would guess that maybe in a very rough approximation, a year, we will start seeing something that actually changed according to users' discussions, but that's only a guess.
You mentioned the Internet of Languages just now. Could you elaborate on what that is?
Yes. The point is to not impose one language on the system, but to allow languages to evolve. Now, how to make languages evolve? Well, you can take this statement to many directions. If you take it to its full meaning, then you will need languages that interpret each other, just like the distinction in computer science between compiler and interpreter. We need to implement one language in another. And this is impractical. There is a reason why. In software development, people work with compilers and less with interpreters because it just doesn't work. It doesn't work well. So we allow, the Internet of Languages is about allowing some ability of languages to evolve and coexist by ability to supply translators from one language to another. Translators being compilers. So to add a new language to the system, you need to specify how this language translates to existing language. And by that, to a very large extent, a lot of languages can coexist. And moreover, not only knowledge representation languages to coexist, but also various formats. For example, you have some knowledge base. Sometimes you want to translate it into HTML format, to a website. Sometimes you want to translate it to a wiki format.
Yeah, thank you for that explanation of what the Internet of Languages is. And what are some of the biggest milestones that you think Tau has reached over the past year and moving forward into the next year? What other milestones do you think that you guys are planning on achieving?
I think the biggest two things in the last year are the team that grew up and our academic panel, including Professor Franconi. We have leading researchers from the field and we have very good development team. In the first years of IDNI, I was completely by myself, but now it's not the case. And now we have an amazing team that we're working on Tau. And the second big thing from the last year is that we managed to find a very good solution to the logical problem that I presented before. So not only we solved it, but it is also a very good solution.
And moving forward into the next year, what type of milestones are you hoping to actually achieve?
So to implement this language that allows methodological self-referential statements, to implement a proof of execution, the sum-check protocol, which I spoke about, and to start a blockchain defined by its users.
Wow, thank you. That sounds amazing. I can't wait to see what Tau actually comes up with over the future and the next couple of years. And I'm sure a lot of my viewers who are watching this video, they are also going to be really interested in what Tau is developing and maybe even planning on using your product. Thank you so much.